You've heard the words before, probably more times than you can count. Big Bang, an explosion, a single point, smaller than an atom, suddenly detonating into everything that exists, all at once. It's the version taught in schools, repeated endlessly in documentaries, printed in textbooks with a cartoon fireball graphic sitting right next to it. And it is, in the most important sense that actually matters here, wrong. Not wrong in some minor, forgivable, technical way physicists quietly argue about at conferences. Wrong in a way that, once you actually understand it, makes the true story so much stranger, so much more violent, and so much more personal than anything you were handed as a kid. There was no explosion, not in the sense anyone ever pictures it. There was no fireball lighting up an empty void. There wasn't even, in any sense you could actually picture in your head, a before for anything to happen inside of. And somewhere in the 13.8 billion years between that first impossible moment and you, sitting here right now, reading this sentence, something happened that never should have been allowed to happen at all. The universe, by its own rules, should not exist. You should not exist. And yet, here you are, made of atoms forged inside the exploding hearts of stars that died so violently that some of them briefly outshone entire galaxies, atoms that traveled across billions of years and trillions of miles just to end up, by pure accident, arranged into the exact shape that lets you read these words and wonder what any of it means. This is the real story, not the cartoon version, the one that involves a war between matter and its own evil twin, 100 million years of total darkness, stars so massive they lived for less time than it takes to build a pyramid, a single planet-sized cannonball that hit Earth so hard it ripped off the piece that became the moon, and a chain of accidents so specific that changing any single one of them means you were never born at all. Stay with me all the way to the end, because by the time we get there, you're genuinely never going to look up at the night sky the same way again. Let's start by killing the cartoon. When people picture the Big Bang, they picture an explosion happening somewhere, in some location, in a universe that was already sitting there, empty, waiting for something to go boom inside it. That picture is completely backward. There was no empty space waiting around for the Big Bang to happen in. Space itself did not exist yet. Time did not exist yet. The Big Bang wasn't something that happened inside the universe. It was the universe, everywhere, all at once, from the very first instant, already infinite or already unimaginably vast, simply in an incredibly hot, incredibly dense state, and then expanding. Not exploding outward into a pre-existing emptiness like a grenade. Stretching. Space itself was stretching. Everywhere. Simultaneously. The same way the surface of a balloon stretches when you blow into it, except there was no outside of the balloon, and there was no center, and there was no edge. Here's the part that breaks most people's brains the first time they actually hear it explained properly. Ask a physicist, what happened before the Big Bang? And the honest answer isn't, we don't know yet. The honest answer is that the question itself might not even make sense, the same way asking, what's north of the North Pole, doesn't make sense. Time, as a dimension you can move backward or forward through, appears to have started at that moment. Not, started ticking earlier and we just can't see it. Started. There may be no before. The same way there's no direction further north than the northernmost point on Earth. You can spend the rest of your life sitting with that sentence and never fully settle into it. And that's not a failure of your imagination. That's just what happens when the universe's actual origin turns out to be stranger than anything human language was originally built to describe. And here's the twist most people never even hear about. The one that turns "the universe began" into something closer to a horror story. In the first unimaginably tiny fraction of a second, less than a trillionth of a trillionth of a trillionth of a second, something called cosmic inflation happened, a period where space itself expanded so violently, so much faster than the speed of light, that a region smaller than a single atom ballooned out to a size larger than our entire observable universe today, all before that first tiny fraction of a second had even finished. Nobody fully knows what triggered it. Nobody fully knows what stopped it. We only know it happened because of the fingerprints it left behind in the oldest light in existence, fingerprints we're going to come back to later, because they might be the closest thing to a photograph of creation itself that human beings will ever get to see. Now, here's the part of the story that almost nobody tells you, the part that should genuinely disturb you once you understand what it actually means. In that first insanely hot, insanely dense moment, the universe should have destroyed itself before it even had the chance to begin. Here's why. Every single time energy converts into matter, which is exactly what was happening constantly in that first fraction of a second, it's supposed to create two things at once, in perfectly equal amounts: a particle and its exact opposite twin, called an antiparticle, an electron and an anti-electron, a proton and an antiproton, matter and antimatter, created together, always in equal amounts, according to every equation physicists have ever written. And here's the problem. When matter touches antimatter, they don't coexist. They annihilate each other, completely, instantly, converting entirely back into pure energy, leaving nothing behind. If the early universe really did create matter and antimatter in perfectly equal amounts, exactly the way the math says it should have, then every single particle should have found its antimatter twin in that first violent instant, annihilated completely, and the entire universe should have ended as a flash of pure light and absolutely nothing else. No stars, no galaxies, no planets, no you, just an empty, silent, forever expanding fog of photons with not a single atom of matter left anywhere inside it. That obviously did not happen, and physicists genuinely do not fully understand why. Somewhere in that first fraction of a second, for reasons still not completely understood, matter won by the tiniest possible margin. For every billion antimatter particles created, the universe apparently created 1,000,000,001 matter particles. That's it. That's the entire margin. One extra particle for every billion pairs. All that annihilation still happened, on a scale that's almost impossible to picture, and it's actually where most of the light in the universe, the leftover glow we can still detect today, actually came from. But that one tiny, unexplained imbalance, 1 part in 1,000,000,000, survived the destruction. Every star, every planet, every atom in your body is made entirely out of that leftover 1,000,000,000th. You are not just made of stardust. You are made of the universe's rounding error, the tiny accounting mistake that let matter exist at all. And nobody currently knows why the mistake happened, only that if it hadn't, there would be nothing here to ask the question. So the universe survives its own near suicide, and what's left is a searingly hot soup of leftover matter, way too hot for atoms to exist at all, just loose particles slamming into each other trillions of times a second. And in the first 3 minutes, and this is not an exaggeration, physicists can actually calculate what happened minute by minute. The universe cooked up the first ingredients of everything that would ever exist. Protons and neutrons started fusing together, the same basic process that powers the sun, building the very first atomic nuclei: hydrogen, helium, and just a trace of lithium. That's it. That's the entire recipe the early universe had time to cook before things cooled down too much for fusion to continue. 3 minutes, and then the pot goes cold. Here's the detail that should stop you cold, because it's the setup for everything else in this entire story. Every heavier element, every single atom of carbon, oxygen, nitrogen, iron, gold, everything that makes up the actual physical stuff of planets and oceans and bones and blood, none of it existed yet. None of it. The early universe, fresh out of its first 3 minutes, was almost entirely hydrogen and helium, two of the simplest, most boring elements on the periodic table, and absolutely nothing else. There was no rock. There was no water. There was no metal. If you had been able to stand somewhere and watch the universe at this stage, you would have seen nothing but a vast, glowing, expanding cloud of the simplest gas imaginable, containing, at that exact moment, 0% of the raw material needed to ever build a planet like Earth, let alone a person to stand on it. Everything you're about to hear for the rest of this story is really just the long, detailed, carefully verified answer to one single question. How do you get from a universe made of nothing but hydrogen and helium, drifting silently through the dark, to a universe that eventually contains you? And the answer, when you actually walk through it step by step, carefully, patiently, without skipping any of the genuinely improbable parts, is one of the most violent, most improbable, and most quietly beautiful chains of events that has ever happened anywhere, at any point, in the entire history of existence. For the next 380,000 years, nothing happens that you could actually watch, not because nothing was going on, but because the universe was, quite literally, too bright to see anything in. The entire cosmos was filled with a hot, dense fog of charged particles, electrons and protons flying around freely, and light simply could not travel through it. Every single photon that tried to move got smacked into an electron almost immediately, scattered, bounced, absorbed, and re-emitted, over and over, endlessly, the same way light can't travel more than an inch through a thick fog on a highway. The universe wasn't dark during this period. It was blindingly, uniformly bright, everywhere, all the time, and completely, permanently opaque. If light itself couldn't escape more than a fraction of an inch in any direction, nothing else could either. Then, 380,000 years after the beginning, something changed everything. The universe had finally expanded and cooled enough, down to about 5,000 degrees Fahrenheit, roughly the surface temperature of a red star, for electrons to finally slow down enough to be captured by protons, forming the very first stable, neutral atoms in the history of existence. And the instant that happened, everywhere, all at once, throughout the entire universe, the fog lifted. light was suddenly free to travel in a straight line for the first time ever. Physicists call this moment recombination, and it released an enormous, universe-wide flash of light that has been traveling freely in every direction ever since. That light is still out there, right now, tonight. It's called the cosmic microwave background, and it's the oldest light in existence, stretched and cooled by nearly 14 billion years of cosmic expansion until it's no longer visible light at all, just a faint microwave hiss filling the entire sky in every direction, equally, all the time. If you've ever seen static on an old analog television, a small percentage of that random noise, roughly 1%, was literally caused by photons from the birth of the universe hitting the antenna. You've probably watched the afterglow of creation itself flickering on a television screen and had absolutely no idea what you were looking at. That flash of light, from 380,000 years after the beginning, is the earliest baby picture the universe has ever allowed anyone to take. And we've been staring at it, studying every tiny imperfection in it for decades, because those imperfections are about to become the single most important detail in this entire story. And then, right after that flash of first light, the universe does something genuinely unsettling. It goes dark, completely, totally dark, for the next 100 million years, in a period astronomers actually call the Cosmic Dark Ages, and it's exactly as creepy as it sounds. There were no stars yet. There were no galaxies yet. There was nothing in the entire universe producing light of any kind at all, just an enormous, expanding, cooling cloud of neutral hydrogen and helium gas, drifting through absolute blackness for 100 million years, with nothing, anywhere, to see it. Picture that for a second, because it's genuinely hard to hold in your head. 100 million years is roughly the amount of time between the peak of the dinosaurs and right now, an entire, almost unimaginable span of deep time. And during that entire stretch, the universe simply sat there, cold, dark, and empty, containing all the raw material that would eventually become every star, every planet, and every living thing that has ever existed, and doing absolutely nothing with any of it. If you could somehow travel back and float inside that 100 million year darkness, there would be nothing to see in any direction, forever. An emptiness so complete that light itself had nothing to travel toward. What finally broke the darkness wasn't some single dramatic event. It was gravity, patiently, quietly doing its job. Tiny, almost imperceptible differences in density, leftover ripples from the earliest moments of the universe, the same ripples that show up as imperfections in that first flash of light we just talked about, slowly pulled hydrogen and helium gas together, denser and denser, over tens of millions of years, into enormous, slowly collapsing clouds. And somewhere inside those clouds, the pressure and temperature at the core finally climbed high enough to do something the universe had never done before. Not once in its entire existence up to that point. It ignited nuclear fusion. The first star in the history of the universe turned on, and the darkness, after 100 million years, finally ended. Here's where the story gets genuinely violent, because the very first generation of stars, astronomers call them population 3 stars, were nothing like the sun, and nothing like almost any star you could point to in the night sky today. Remember, at this point in cosmic history, there was still no carbon, no oxygen, no heavier elements of any kind, nothing but hydrogen and helium, the two simplest, lightest elements in existence. And it turns out that when you try to build a star out of nothing but hydrogen and helium, without any heavier elements to help the collapsing gas cloud cool down and fragment into smaller pieces, gravity doesn't stop pulling material together at a reasonable size. It just keeps going. The very first stars in the universe are believed to have been absolute monsters, potentially hundreds of times more massive than our Sun, burning with a violence and a brightness that dwarfs almost anything that exists in the universe today. And here's the brutal part. The bigger a star is, the faster it burns through its fuel, and the faster it dies. Our own Sun, a fairly ordinary mid-sized star, will burn steadily for about 10 billion years total. Those first monster stars, hundreds of times more massive, are estimated to have lived for as little as a few million years, some perhaps only a few 100,000, before running out of fuel entirely and dying in the most violent way physics allows. A hypernova, an explosion so powerful it makes an ordinary supernova look gentle by comparison, briefly outshining an entire galaxy, and in some cases so powerful it may have completely obliterated the star, leaving nothing behind at all, not even the black hole a normal massive star would collapse into. This is the part of the story that almost never gets told, and it should genuinely change how you think about the phrase, "We are made of stardust." Those first stars, the monsters, born only 100 million years after the beginning of everything, lived unimaginably short, unimaginably violent lives. And in dying, they did something the universe had never done before. Inside their cores, and in the unbelievable heat and pressure of their own explosive deaths, they forged the first heavy elements to ever exist: carbon, oxygen, silicon, iron, the actual raw ingredients of every rocky planet, every ocean, and every living cell that would ever come to exist, anywhere. Before those first stars died, the universe was incapable, physically incapable, of ever building something like Earth. Their deaths were the first moment that possibility ever existed at all. Those first monster stars weren't scattered randomly. They were born clustered together in the densest pockets of gas, and their gravity, combined with the gravity of an invisible, mysterious substance called dark matter, which was already quietly shaping the structure of the universe from the very beginning, pulled surrounding gas and newly forming stars into the very first galaxies. Small, chaotic, violently star-forming structures completely unlike the calm, orderly spiral galaxies we're used to seeing in photographs today. And as more and more of these first galaxies lit up across the universe, something else started happening on a truly cosmic scale, a process astronomers call reionization. Remember all that neutral hydrogen gas left over from the Dark Ages, spread throughout the entire universe? The intense radiation pouring out of all these newly forming stars and galaxies was powerful enough to rip the electrons back off those hydrogen atoms, reionizing the gas that had only just settled down 380,000 years after the beginning. This took hundreds of millions of years to complete across the entire universe, essentially undoing, region by region, the exact process that had allowed the first flash of light to escape in the first place. By roughly 1 billion years after the beginning, reionization was essentially finished, and the universe had transformed, in less than 1 billion years, from a smooth, dark, featureless cloud of gas into a chaotic, brightly lit landscape of forming galaxies, all pulled together by the invisible scaffolding of dark matter, all still churning with the violent, short-lived deaths of the very first generation of stars. Here's the thing that should genuinely blow your mind about this stage of the story. The James Webb Space Telescope, launched in December 2021, has actually managed to photograph galaxies from this exact era, capturing light that has been traveling toward us for over 13 billion years, showing galaxies as they actually looked when the universe was less than 5% of its current age. And what it found surprised almost everyone. Some of these incredibly early galaxies appear larger, brighter, and more fully formed than anyone's models predicted they should be. This early in cosmic history, suggesting that whatever process builds galaxies out of raw hydrogen and dark matter might work faster and stranger than physicists currently understand. We are, right now, in real time, still discovering that this part of the story isn't fully finished being written. Now here's where the story becomes genuinely, personally about you. Because building a planet like Earth wasn't a one-step process. It took generation after generation of stars living, dying, and seeding the universe with slightly heavier elements each time, an assembly line running for billions of years before the raw materials existed to build anything resembling home. Every star spends most of its life fusing hydrogen into helium in its core, the same basic process happening inside our own sun right now, at this exact second, releasing the energy that eventually reaches Earth as sunlight. But once a sufficiently massive star runs out of hydrogen fuel, it doesn't just switch off. It starts fusing helium into carbon and oxygen. Once that fuel runs out too, in the most massive stars, it keeps going, fusing carbon into neon, neon into oxygen, oxygen into silicon, and finally silicon into iron, each stage happening faster and hotter than the last, building up layer after layer inside the star like the world's most violent onion, each layer made of a heavier element than the one surrounding it. And then, the moment a massive star's core finishes converting into iron, everything goes catastrophically wrong, in a matter of literal seconds. Iron is the one element a star cannot get any usable energy from fusing, the absolute dead end of the entire process. The instant a star's core becomes iron, fusion stops producing outward pressure entirely, and gravity, which has been fighting against that outward pressure for the star's entire multi-million-year life, wins instantly and completely. The core collapses in on itself in less than a second, an entire region larger than Earth crushing down to the size of a city, and the resulting shockwave slamming into the outer layers of the star that are still falling inward, triggers a supernova, an explosion so violent it can briefly outshine every other star in its entire galaxy combined. And this is the moment, the actual literal moment, when almost every heavy element heavier than iron gets created. Gold, platinum, uranium, forged in the unbelievable violence of that single explosive second, and then flung outward across space at incredible speeds, seeding the surrounding gas clouds with exactly the raw materials needed to eventually build rocky planets. Every gold ring, every iron nail, every calcium atom in your bones was either built quietly, over millions of years, inside a dying star's core, or forged in the literal seconds of a star's explosive death. You are not just made of stardust in some poetic sense. You are made of the specific, violent, calculable byproducts of stellar death atoms that traveled across unimaginable distances and unimaginable time purely by chance to end up arranged into you. Fast forward roughly 9 billion years. From the beginning of everything, through generation after generation of stars living and dying and enriching the galaxy with heavier and heavier elements, and somewhere in a fairly ordinary, unremarkable spiral galaxy in a quiet, uncrowded stretch about 26,000 light-years from the crowded, dangerous galactic center, a slowly rotating cloud of gas and dust already enriched with billions of years' worth of stellar leftovers, carbon, oxygen, iron, silicon, sat there, largely undisturbed, until something gave it a push. Most astronomers now believe that push came from a nearby supernova, the explosive death of another massive star, sending a shock wave through the surrounding gas cloud, compressing it just enough to trigger gravitational collapse. And once that collapse started, it fed on itself, the same way it did for every star before it, pulling more and more material into the center, spinning faster and faster as it shrank. The same way a figure skater spins faster by pulling their arms in. 99.8% of all the mass in that collapsing cloud ended up concentrated at the center, compressed and heated until nuclear fusion ignited and a brand new star turned on. Our sun. But that leftover 0.2% didn't just disappear, and this is where things get genuinely chaotic. The remaining gas and dust flattened out into a spinning disk around the newborn sun, called a protoplanetary disk, and inside that disk, tiny particles of dust started sticking together through simple static electricity, forming pebbles, then rocks, then boulders, then objects. The size of small moons called planetesimals in a violent, crowded demolition derby that lasted for millions of years. These planetesimals slammed into each other constantly, sometimes shattering apart, sometimes merging into larger bodies in a chaotic, ongoing collision process that eventually built the planets themselves, layer by layer, impact by impact, out of raw cosmic wreckage. And one of those forming planets, roughly the third one out from the newborn sun, was about to have the single most violent, most consequential collision of its entire early history. One that would determine, in ways nobody could have possibly predicted at the time, whether a planet like Earth could ever end up capable of supporting anything like you. Roughly 4.5 billion years ago, when Earth was still young, still molten in places, still barely finished forming, a rogue planet roughly the size of Mars, one that modern astronomers have named Theia, came screaming through the inner solar system on a collision course with our still-forming planet. This wasn't a glancing scrape. Current evidence suggests it was a genuinely catastrophic, planet-shattering impact, striking Earth at an angle, with enough force to melt and vaporize a staggering amount of material from both worlds, blasting an enormous cloud of molten, superheated debris into orbit around what remained of Earth. Here's the part that should genuinely stop you, because it's easy to say, a planet hit Earth, and let the sentence slide past without actually feeling the scale of it. An object the size of Mars, roughly half of Earth's diameter, striking our planet with enough force to partially melt it, is an event so violent that if it happened today, it would not just end civilization. It would end the planet as a habitable object entirely, converting most of the surface into a globe-spanning ocean of molten rock glowing at thousands of degrees. Earth survived this, barely, as a battered, reshaped, radically altered version of itself, and the debris blasted into orbit, superheated rock and metal, rapidly coalesced over what may have been only a few decades to a few centuries into a single, large satellite, the Moon. And here's the twist that almost nobody realizes when they look up at the Moon on an ordinary night. Without that collision, without that specific, catastrophic, 1 in a billion impact, Earth would almost certainly not have a large moon at all. And the Moon's gravity turns out to be one of the most important, most quietly essential ingredients that ever allowed complex life to eventually evolve here. The Moon's gravitational pull stabilizes Earth's axial tilt, preventing the kind of chaotic, wildly swinging climate variations that would make long-term, stable evolution far more difficult, possibly impossible. Without the Moon, computer simulations suggest Earth's tilt could wobble unpredictably over millions of years, sometimes tipping the planet almost completely on its side, creating climate chaos so severe that complex, land-based life might never have had the stable conditions it needed to survive long enough to evolve into anything like you. The single most violent, most destructive event in Earth's entire early history may also be the single most important reason you exist at all. Earth's violence wasn't finished. For the next several 100 million years, the young planet, and the newly formed Moon alongside it, endured a period some scientists call the Late Heavy Bombardment, an era of intense, repeated impacts from leftover asteroids and comets still drifting through the young solar system, some of them large enough to vaporize entire oceans on impact, boiling the surface into superheated steam again and again. If you look at photographs of the Moon's heavily cratered surface, you're looking at a fossilized record of exactly how violent this period actually was. A battering so severe and so relentless that some scientists genuinely debate whether it might have sterilized Earth's surface completely, possibly more than once, resetting any early attempts at life back to absolute zero, over and over, before conditions ever calmed down enough for anything to actually survive. And then, somewhere in the aftermath of all that violence, something happened that remains, to this day, one of the single greatest unsolved mysteries in all of science. Non-living chemistry, ordinary molecules floating in water or clinging to the surface of hot volcanic rock, somehow crossed an invisible line and became alive. Self-replicating, capable of making imperfect copies of itself, copies that could then be shaped, generation after generation, by natural selection. Nobody currently knows exactly how this happened. Scientists have recreated pieces of the puzzle in laboratories, simple organic molecules forming spontaneously under early Earth-like conditions, self-replicating RNA fragments assembling under the right chemical conditions, but the full, complete jump from ordinary chemistry to genuine evolving life has never once been fully recreated from scratch, by anyone, anywhere, despite nearly a century of dedicated research. Here's what should genuinely unsettle you about this part of the story. It happened only once, as far as we can tell. Every single living thing on Earth, every bacterium, every mushroom, every whale, every human being who has ever lived, descends from that exact same single origin event, the same original spark of self-replicating chemistry, inherited unbroken across nearly 4 billion years. We are, every one of us, distant cousins of literally everything alive, connected by an unbroken chain stretching back to one specific, still mysterious moment, when the universe, for the very first time in its entire 13.8 billion year existence, produced something capable of actively fighting against its own decay, copying itself, adapting, and eventually evolving into something curious enough to ask where it came from in the first place. For the next roughly 1.5 billion years after life first appeared, it stayed almost impossibly simple, nothing but single-celled microbes, drifting in the oceans, doing essentially the same basic things over and over, for a span of time so long it's almost impossible to picture. And then, life did something that should genuinely be remembered as the first great villain origin story in the history of the planet. A group of microorganisms called cyanobacteria evolved a genuinely revolutionary trick: photosynthesis, the ability to use sunlight to convert water and carbon dioxide into energy, releasing oxygen as a waste product. This sounds harmless, even beneficial, until you understand what oxygen actually was to almost every other living thing on the planet at the time: a deadly, corrosive poison. Nearly all early life on Earth had evolved in an atmosphere with essentially no free oxygen at all, and to those organisms, oxygen was a violently reactive, cell-destroying toxin, the same way it's toxic to many anaerobic bacteria today. As cyanobacteria spread across the ancient oceans, quietly, relentlessly, pumping oxygen into the water and eventually into the atmosphere itself, over hundreds of millions of years, they triggered what scientists now call the Great Oxidation Event, roughly 2.4 billion years ago. And it may have been the single largest mass extinction in the entire history of life on Earth, wiping out the vast majority of species alive at the time, all of them poisoned, slowly and completely, by the literal exhaust fumes of a group of microscopic organisms that had simply figured out how to eat sunlight. Here's the twist that turns this from a horror story into something closer to a redemption arc. That same oxygen, the thing that functioned as an extinction-level poison for billions of earlier organisms, is the exact same gas you are breathing right now, this second, to stay alive. The organisms that eventually evolved to tolerate, and then actually depend on, oxygen for a vastly more efficient form of energy production went on to become the ancestors of every complex, multicellular organism that would ever exist, including, eventually, you. The Great Oxidation Event was simultaneously the worst mass extinction in Earth's history and the single event that made complex, energy-hungry life like animals, and eventually human brains, possible at all. Life's first great act, on a planetary scale, was accidentally poisoning almost everything alive at the time, and then, slowly, turning that poison into the very fuel that would eventually power you. And then, as if the planet hadn't been through enough already, Earth nearly froze itself to death, possibly more than once. Geological evidence suggests that somewhere between roughly 720 and 635 million years ago, Earth entered a period so cold that ice may have covered the entire planet, from pole to pole, oceans included, in an event scientists call Snowball Earth. Ice, unlike open ocean or bare rock, reflects sunlight back into space instead of absorbing it, which means once a planet gets cold enough for ice to start spreading toward the equator, the process can spiral out of control, reflecting away more and more sunlight, causing more and more cooling in a runaway feedback loop that, in Earth's case, may have resulted in a completely frozen world, with an average global temperature plunging to somewhere around negative 50 degrees Fahrenheit for millions of years at a stretch. How does a completely frozen planet ever thaw back out? The same slow, patient process that had already reshaped Earth's history several times before. Volcanoes. Volcanic eruptions continued releasing carbon dioxide into the atmosphere throughout the frozen period, and with no liquid water or exposed rock available to absorb it through normal geological cycles, that carbon dioxide simply kept accumulating year after year for millions of years, eventually building up to concentrations high enough to trigger an extreme greenhouse effect, thawing the ice dramatically, and possibly plunging the planet from a frozen wasteland into an intensely hot, humid hothouse world within a geologically short span of time. And here's the part of the story that connects this frozen catastrophe directly to everything that came after. Many scientists believe the extreme environmental stress of these repeated snowball Earth events may have acted as an evolutionary pressure cooker, driving simple, ancient microorganisms toward genuinely new adaptations and setting the stage for one of the most important evolutionary leaps in the entire history of life: the emergence of complex eukaryotic cells, the direct ancestors of every plant, fungus, and animal that would ever exist. This leap itself hinged on an event nearly as strange as anything else in this story: one simple cell somehow absorbing another simple cell and keeping it alive inside itself in a permanent partnership. An event called endosymbiosis, which, as far as the fossil and genetic record can tell, happened exactly once in the entire 4 billion year history of life on Earth, and became the ancestor of every complex cell in your entire body, right now, including every single one of the roughly 37 trillion cells currently keeping you alive. For roughly another billion years after that, life stayed simple and small, mostly single cells, and, eventually, basic multicellular organisms. Nothing that would look particularly exciting if you happened to be standing on the ancient shoreline watching it happen. And then, roughly 540 million years ago, something happened so sudden and so dramatic that scientists simply call it the Cambrian explosion. And the word explosion genuinely isn't an exaggeration here. In a geological instant, a span of only about 20 to 25 million years, which sounds long until you realize it's less than 1% of Earth's total history. Nearly every major animal body plan that exists today, and quite a few bizarre ones that don't exist anymore at all, suddenly appeared in the fossil record, essentially all at once. Before the Cambrian explosion, life was simple blobs and mats. After it, the oceans were suddenly full of eyes, legs, shells, jaws, and predators actively hunting other complex animals for the first time in the entire history of the planet. Nobody fully agrees on exactly what triggered this sudden burst of complexity, though rising oxygen levels, the development of the first hard shells and skeletons, and an evolutionary arms race between newly evolved predators and prey are all leading candidates. What matters for our story is what came next: an explosion of evolutionary experimentation, followed by hundreds of millions of years of animals slowly, gradually diversifying, dying out, and diversifying again through a brutal, repeating cycle of mass extinctions and recoveries. The most famous of these extinctions happened 66 million years ago, when an asteroid roughly 6 miles wide slammed into the Yucatan Peninsula with the force of billions of nuclear weapons detonating simultaneously, triggering wildfires, tsunamis, and a global cloud of dust and debris that blocked sunlight for months or years, collapsing food chains worldwide and wiping out roughly 75% of all species on the planet, including every non-avian dinosaur that had ever lived, ending an era in which dinosaurs had already dominated Earth for over 160 million years, a span of time more than 800 times longer than modern humans have existed as a species. And here's the twist that turns catastrophe into opportunity. The same pattern we've now seen repeated over and over throughout this entire story. With the dinosaurs gone, small, previously overshadowed mammals, tiny, nocturnal, shrew-like creatures that had spent tens of millions of years hiding in the shadows of much larger reptiles, suddenly found an entire planet's worth of empty ecological niches waiting to be filled. Within just 10 million years, an eye blink by geological standards, mammals rapidly diversified into an enormous variety of new forms, eventually giving rise, tens of millions of years later, to primates, and eventually to a single specific branch of that primate family tree that would go on to do something no other species in the entire 4 billion year history of life on Earth had ever managed to do before. That species was us. And the story of how we actually got here is stranger and far more precarious than the tidy, single-line evolutionary chart you probably saw in a textbook growing up. Human evolution wasn't a straight line marching steadily upward from ape to man. It was a messy, branching bush with multiple different species of early humans, Homo habilis, Homo erectus, Homo neanderthalensis, and several others, existing at overlapping times, sometimes competing for the same territory, sometimes, as genetic evidence has now confirmed, interbreeding with each other. Modern humans, most non-African populations alive today, still carry somewhere between 1 and 2% Neanderthal DNA in their genomes, a direct genetic fingerprint left behind by encounters between our species and a close evolutionary cousin that eventually went extinct roughly 40,000 years ago, for reasons still debated among scientists. And here's a detail almost nobody hears about, one that makes our own existence feel considerably less inevitable than it usually gets presented. Genetic evidence suggests that at some point in our species' deep past, possibly connected to a massive volcanic eruption roughly 74,000 years ago, the entire global population of Homo sapiens may have been squeezed down to somewhere between a few thousand and 10,000 breeding individuals, a population bottleneck so severe that every single human being alive today, all 8 billion of us, may be descended from that startlingly small founding group. We came, by some estimates, uncomfortably close to not existing at all, as a species, tens of thousands of years before anyone was around to write down what almost happened. What finally separated us from every other species in the entire 4 billion year history of life wasn't just intelligence in some vague sense. Plenty of animals show flashes of problem-solving and tool use. It was something more specific, the ability to accumulate knowledge across generations, building on what came before rather than starting over each time, layering discovery on top of discovery, language on top of language, technology on top of technology, until a species that spent nearly its entire existence as small, vulnerable groups of hunter-gatherers eventually built telescopes, split atoms, and figured out, using nothing but careful observation and patient mathematics, the entire story we've just walked through together, from a universe with no matter in it at all, to a version of that same universe capable of looking back at its own 13.8 billion year history and asking, out loud, how any of it actually happened. Let's actually sit with the odds for a second, because when you stack every single step of this story on top of each other, the final result should feel less like an inevitable outcome and more like a genuinely absurd stroke of luck. The universe needed to survive its own matter-antimatter near suicide by a margin of 1 part in a billion. It needed the very first generation of monster stars to live fast and die violently enough to forge the first heavy elements. It needed multiple further generations of stars to keep building heavier elements and then explode in exactly the right way to scatter them across space. It needed a completely ordinary cloud of leftover cosmic debris to get pushed, probably by a random nearby supernova, into collapsing into our specific solar system. It needed a rogue, Mars-sized planet to slam into early Earth at exactly the right angle to create a moon capable of stabilizing our climate for billions of years afterward. It needed non-living chemistry to somehow cross the line into self-replicating life, an event that has never been recreated and never been fully explained. It needed that life to survive repeated global freezes, repeated mass extinctions, an asteroid impact capable of ending the age of dinosaurs, and a genetic bottleneck that may have reduced our entire species down to a few thousand individuals. Change literally any single one of those steps, even slightly, and you're not reading this sentence right now. There is no version of this story where you exist if that first monster star had lived a little differently, if that asteroid had missed Earth by a few hours' worth of orbital timing, if that ancient volcanic winter had lasted a little longer than it did. This isn't meant to make you feel insignificant. It's meant to do the opposite. You're not a random, forgettable accident floating through an indifferent universe. You are the specific, improbable, unrepeatable result of 13.8 billion years of things going right just often enough, against odds so overwhelming that no honest mathematician would have bet on the outcome if you'd asked them to calculate it in advance. And here's the part of the story most documentaries never get to, the plot twist that changes everything you've just heard. Because the universe you're living in right now isn't even mostly made of the stuff we just spent this entire story building. Everything, every star, every planet, every atom in your own body, every single thing we've described tonight belongs to only about 5% of everything that actually exists. Here's the number that should genuinely rattle you, more than almost any other number in this entire story, once you actually let it sink in properly. Ordinary matter, everything made of atoms, every star, every planet, every living thing that has ever existed anywhere in the universe makes up roughly 5% of the total mass and energy of everything that exists. The remaining 95% is split between two things. Scientists still cannot fully explain. Dark matter, an invisible substance that doesn't interact with light at all, detectable only through its gravity, and dark energy, a mysterious force actively pushing the entire universe apart, faster and faster, for reasons nobody currently understands. We know dark matter exists because galaxies spin far too fast to hold themselves together, using only the gravity of their visible stars, a mystery first noticed in the 1930s and confirmed decisively in the 1970s by astronomer Vera Rubin, whose careful measurements proved that every galaxy must be wrapped in an invisible halo of extra mass several times heavier than all its visible stars combined, simply to keep from flying apart. We know dark energy exists because of a discovery in 1998 that shocked the entire field of astrophysics. Distant exploding stars revealed that the universe's expansion isn't slowing down under gravity's pull, the way everyone expected it should. It's speeding up, accelerating. For reasons physicists still cannot explain with any real confidence, despite decades of dedicated research and some of the most sensitive scientific instruments ever built. This means everything in tonight's entire story, the first 3 minutes of fusion, the 100 million years of darkness, the monster stars and their violent deaths, the asteroid impact that killed the dinosaurs, your entire existence, all of it, unfolded inside the smallest, least significant slice of everything that actually exists. The real story of the universe isn't just the one we can see and touch and measure directly. It's also, overwhelmingly, a story about something we still can't identify, still can't detect directly, and still can't fully explain, quietly shaping the structure of every single galaxy in the sky, and actively determining, right now, exactly how this entire story is eventually going to end. So how does this story actually end? Because unlike the beginning, which is buried in mystery and math too extreme for ordinary language, the ending is something scientists can actually calculate. And the answer is genuinely one of the strangest, most quietly unsettling conclusions in all of modern physics. If dark energy keeps behaving exactly the way it's behaving right now, the accelerating expansion of the universe is simply going to continue, forever, carrying galaxies apart from each other faster and faster, dragging the entire observable universe toward an increasingly cold, increasingly empty, increasingly lonely future. In roughly 100 billion years, nearly every galaxy currently visible in our night sky will have been pushed so far away by the ever-accelerating expansion of space itself that its light will simply never reach us again, vanishing permanently over a cosmic horizon that keeps creeping closer with every passing year. Any civilization existing at that point in the far future, looking up at their own night sky, would see only the merged, aging remnant of our own galaxy and its nearest neighbor, Andromeda, surrounded by an otherwise empty, silent darkness, with absolutely no evidence remaining that trillions of other galaxies had ever existed at all. Trillions of years beyond that, as existing stars gradually burn through their fuel and the raw material needed to form new stars becomes increasingly scarce, the entire universe would slowly, gradually go dark again, star by star, galaxy by galaxy, cooling toward an almost featureless, eternal near-absolute zero stillness that some physicists call the Big Freeze, or, more ominously, heat death. Here's the detail that should genuinely give you chills, because it connects the very end of this story directly back to its very beginning. The universe started in total darkness, spent 100 million years in total darkness, and if current models hold up, it's going to end. Trillions of years from now, in total darkness again. An almost perfect mirror image of how everything began. Except this time, in between those two vast stretches of silence, for one brief, almost unimaginably narrow window of cosmic time, measured in mere billions of years against a future that could stretch on essentially forever, there were stars, there were planets, there was life, and, for one specific, improbable, unrepeatable moment, there was you, here, right now, alive long enough to actually learn the story before it eventually, quietly, comes to an end. But before we get to that far future, there's a closer, stranger twist in this story worth telling, because it turns out the ending of the universe isn't the only mystery still sitting unsolved. There's a much more immediate, much more personal question hanging over everything we've just walked through, and it has to do with whether any of this ever happened anywhere else. The Milky Way alone contains somewhere between 200 billion and 400 billion stars, and current estimates suggest most of them host at least one planet, which means our own galaxy alone likely contains something like 1 billion potentially habitable Earth-like worlds. 1 billion chances for that exact same impossible chain of events, matter surviving its own near annihilation, monster stars forging heavy elements, a moon-forming collision stabilizing a planet's climate, non-living chemistry crossing the line into life, to happen all over again, somewhere else, on some other spinning rock, orbiting some other star. And yet, after pointing our best instruments at the sky for over 60 years, listening on every frequency we know how to listen on, scanning millions of stars for any hint of an artificial signal, we have found exactly nothing. Not one confirmed transmission, not one confirmed visit. Just silence, everywhere, across a galaxy that, by the math alone, should be absolutely full of other versions of this exact same story playing out in parallel. Physicist Enrico Fermi asked the obvious question out loud back in 1950, almost as a throwaway comment over lunch. If the universe is this old and this big, and produces habitable planets this reliably, then where is everybody? Nobody has ever given him a fully satisfying answer. Maybe the chain of events we just walked through really is that rare, so improbable, that Earth might be one of the only places in the entire galaxy where every single link happened to line up correctly. Maybe intelligent life is common, but something about the specific technological stage we're currently passing through, nuclear weapons, engineered biology, artificial intelligence, quietly destroys almost every civilization that reaches it, before it ever gets the chance to reach the stars and announce itself to anyone else. Or maybe, and this is the possibility that should genuinely keep you up at night in a good way, we simply haven't looked long enough, or in the right way, yet. And the real story of the universe includes a chapter we haven't gotten to read at all, one where the silence finally breaks. And it turns out we were never actually as alone as 60 years of quiet static made it seem. Here's a possibility that sounds like science fiction, but comes directly out of the same physics that explains cosmic inflation, the violent, faster-than-light stretching that happened in that first unimaginable fraction of a second after the beginning. Some physicists, working through the actual mathematics of inflation, rather than speculating for fun, have proposed that inflation may never have fully stopped everywhere at once. Instead, inflation might have ended in our specific patch of space, creating the universe we actually observe, while continuing on forever in other regions, endlessly spawning new bubbles, each one becoming its own separate universe, with its own separate Big Bang, potentially its own separate laws of physics entirely. This idea is called eternal inflation, and it implies something almost too large to hold in your head. Our entire 13.8 billion year, 100 billion galaxy universe might be just one bubble, one single event. Inside an endless, ever-expanding foam of other universes we can never see, never visit, and never receive a single photon of light from, ever, because the space between bubbles is expanding faster than light itself could ever cross it. This isn't proven. It might never be provable in any strict experimental sense, because by definition, other bubble universes lie completely outside anything we could ever observe or measure, forever cut off by the same relentless cosmic expansion that's already carrying distant galaxies beyond our own observable horizon. But it emerges directly from taking the actual, well-tested mathematics of cosmic inflation seriously and following it to its logical conclusion, rather than assuming inflation politely stopped everywhere at exactly the same moment just because that would be more convenient for us to think about. If eternal inflation turns out to be correct, then the real story of the universe isn't really the story of one universe at all. It's the story of one single bubble, floating in something unimaginably larger, a story so vast that the entire chain of events we just spent this whole documentary walking through, from the birth of matter to the birth of you, might represent nothing more than a single, forgettable page in a book with no last page at all. This is exactly the kind of idea that should make you feel two completely opposite things at the exact same time, and both of those feelings are completely correct. On one hand, genuinely, cosmically small, a single bubble in an endless foam, a single planet in a single galaxy among hundreds of billions, a single story among what might be an infinite number of other stories happening in universes we will never, ever get to see. And on the other hand, genuinely, irreplaceably significant, because even if there are infinite other bubbles out there, this exact chain of events, this exact universe, this exact planet, and this exact version of you, reading this exact sentence at this exact moment, only happened once, and whatever else might be out there, none of it changes the fact that you are here, now, actually experiencing it. Here's a question worth pausing on before we go any further, because it's the kind of question that should actually increase how amazed you are by everything we've covered tonight, rather than making you doubt any of it. How do scientists actually know any of this? Nobody was there to watch the Big Bang happen. Nobody photographed the first stars turning on in the darkness. Nobody witnessed the asteroid hit that killed the dinosaurs. So, how does anyone claim to know the details of events that happened billions, or even just tens of millions, of years before a single human being existed to see them? The answer is one of the most genuinely impressive achievements in the entire history of human thought, and it comes down to a simple but powerful idea. Light doesn't lie, and it doesn't disappear. Every photon of light traveling through space carries an exact physical record of the conditions that created it, encoded directly into its wavelength, its intensity, and its precise chemical fingerprint. When astronomers point a telescope equipped with a spectrometer at a distant galaxy, they're not just looking at a pretty smudge of light. They're reading a direct chemical signature revealing exactly what elements exist in that galaxy's stars, because every element absorbs and emits light at extremely specific, unmistakable wavelengths, the same way a fingerprint uniquely identifies a person. This is literally how we know the early universe contained only hydrogen and helium, and how we know exactly which elements each generation of dying stars added to the cosmic mixture afterward. And because light travels at a fixed, unbreakable speed, looking farther away in space is mathematically identical to looking further back in time. A galaxy 10 billion light-years away isn't just far away. It's showing us a direct, unedited photograph of what that galaxy actually looked like 10 billion years ago, because that's how long its light has been traveling to reach us. This is exactly how the James Webb Space Telescope managed to photograph galaxies from the era of reionization, less than 1 billion years after the beginning of everything. It's not speculation. It's not a computer-generated recreation. It's an actual photograph of an actual moment in the actual physical past, arriving at our detectors right now, tonight, carrying a message that left its source before our own solar system had even finished forming. We didn't have to imagine the real story of the universe. We built instruments precise enough to simply read it, directly, off the light itself. There's a second method scientists use to check this story, and it's arguably even more astonishing than reading ancient light, because instead of looking backward in time, it involves actually recreating the conditions of the early universe, here on Earth, inside a machine. The Large Hadron Collider, buried beneath the border of France and Switzerland, is a 17-mile-long circular tunnel where scientists accelerate protons to nearly the speed of light and smash them together, generating, for an unimaginably brief instant, temperatures and energy densities that haven't existed anywhere in the universe since a fraction of a second after the Big Bang itself. In 2012, physicists at the Large Hadron Collider confirmed the existence of the Higgs boson, a particle theorized nearly 50 years earlier, whose associated field is responsible for giving other particles their mass in the first place, a discovery so significant it earned the Nobel Prize in Physics the following year. Without the Higgs field, every particle in existence would zip around at the speed of light with no mass at all, and atoms, stars, planets, and you would never have been able to form in the first place. Confirming its existence wasn't just a nice academic achievement. It was direct physical proof of one of the most fundamental mechanisms underlying literally everything we've discussed throughout this entire story, tested and verified, not through speculation, but through an actual, repeatable experiment. Recreating conditions from a trillionth of a second after the beginning of everything, over and over, thousands of times a second, inside a machine built by human beings on a small rocky planet in an unremarkable corner of an unremarkable galaxy. This is, when you actually stop and think about it, one of the most genuinely remarkable things our species has ever managed to do. We didn't just tell ourselves a story about how the universe began and decide to believe it. We built instruments capable of reading the actual light left over from the earliest moments of existence, and we built machines capable of physically recreating fragments of those same earliest moments, checking our story against reality, over and over, from two completely independent directions, and getting the same answer both times. The real story of the universe isn't a myth, and it isn't a guess. It's one of the most carefully, rigorously verified stories human beings have ever managed to piece together, using nothing but patience, mathematics, and an absolute refusal to simply accept "we'll never know" as a final answer. Let's pull the entire story back together now, because across everything we've just walked through, it's easy to lose the shape of the whole thing, and seeing it laid out in sequence, start to finish, is the only way to really feel the weight of what actually happened. There was no explosion. There was a stretching, everywhere, all at once, from a state so hot and dense that space and time themselves may not have existed as separate things yet. In the first impossibly small fraction of a second, inflation blew a region smaller than an atom out to a size larger than our entire observable universe today. In the moments after that, matter should have annihilated itself completely against its own antimatter twin, and very nearly did, surviving by a margin of one extra particle for every billion pairs destroyed, an unexplained accounting error that is the only reason anything physical exists at all. In the first 3 minutes, the universe fused the simplest possible elements, hydrogen and helium, and then went dark for 380,000 years before releasing its first flash of light, the same light you can still detect today as faint static on an old television. Then came 100 million years of total, silent darkness, ended only when gravity finally pulled hydrogen and helium together, tightly enough to ignite the very first stars, monstrous, short-lived giants that died in explosions violent enough to forge the first heavy elements the universe had ever produced. Generation after generation of stars repeated that same cycle, living, dying, and seeding the cosmos with heavier and heavier elements, until, roughly 9 billion years after the beginning, a nearby supernova's shock wave triggered the collapse of an ordinary cloud of leftover cosmic debris into our own sun and solar system. A rogue, Mars-sized planet slammed into the still-forming Earth, blasting away enough material to create the Moon and stabilizing our planet's climate for billions of years to come. Non-living chemistry somehow crossed the line into self-replicating life, an event that has never been fully explained or recreated. That life nearly poisoned itself to death with its own oxygen, survived repeated global deep freezes, exploded into nearly every animal body plan that exists today, endured an asteroid impact that ended the age of dinosaurs, and eventually, after nearly 4 billion years of unbroken evolutionary chance, produced a species capable of building telescopes precise enough to look back across all 13.8 billion years of this entire story and actually understand it. And here's the detail that should genuinely change how you feel about your own body the next time you catch a glimpse of yourself in a mirror or feel your own pulse under your fingers. Every single atom inside you has its own individual origin story, buried somewhere in this 13.8 billion year chain of events. The hydrogen in every water molecule in your body was forged in the first 3 minutes after the Big Bang, making it, quite literally, the oldest material substance in your entire physical form, older than the Earth, older than the Sun, older than the Milky Way galaxy itself. The calcium in your bones, the iron in your blood, the oxygen in every breath you're taking right now, were forged inside the cores of dying stars, or in the literal explosive seconds of a supernova, sometime in the roughly 9 billion years between the birth of the universe and the birth of our own solar system. This means your body is not a single, unified thing with one shared birthday. It's an assembly, an almost unimaginably intricate collage of atoms with wildly different ages and wildly different histories, some older than the galaxy, some forged in specific, individually violent stellar deaths that happened in specific, individually identifiable regions of space, all of it eventually drifting together over billions of years into the exact cloud of gas and dust that became our solar system, then Earth, then, through nearly 4 billion years of evolutionary accident, into the exact arrangement of atoms that currently makes up you. There is no other arrangement of atoms anywhere in the history of the universe, and possibly anywhere in the entire, unimaginably vast expanse of space, that is exactly, precisely you. Not almost you. Not a version of you. You, specifically, the actual, unrepeatable outcome of every single event in this entire story, happening in exactly the sequence it happened in. Change the timing of a single supernova by a few thousand years, and different atoms end up in different places, and a slightly different version of Earth forms, with slightly different chemistry, leading over 4 billion years of compounding evolutionary differences to an Earth that never produces you at all, possibly never produces anything resembling humanity at all. You are not just made of stardust. You are a specific, unrepeatable answer to a math problem that has been running continuously for 13.8 billion years. And this is the only time in the entire history of existence that this particular answer has ever come out. Let's make this feel real, on a scale you can actually hold in your head, because 13.8 billion years is a number so large that it stops meaning anything the moment you hear it. Compress the entire history of the universe into a single calendar year, January 1st at midnight representing the Big Bang, and this exact moment, right now, representing midnight on December 31st. On that compressed calendar, the Milky Way doesn't form until March. Our own Sun and Earth don't appear until early September. The very first simple life on Earth shows up around September 21st. The Cambrian explosion, the sudden burst of nearly every animal body plan, happens around December 17th. Dinosaurs arrive on December 24th and go extinct on December 30th at around 6:30 in the evening. Modern humans, our entire species, doesn't appear until 11:52 p.m. On December 31st, just 8 minutes before the entire cosmic year runs out. Every single thing you have ever personally experienced, every conversation, every sunrise, every person you've ever loved, fits inside the final fraction of a second of that final 8-minute sliver. And the specific technological era we're living through right now, the one capable of building telescopes powerful enough to photograph the birth of the first galaxies, and particle accelerators powerful enough to recreate the conditions of the first trillionth of a second, occupies something smaller than the very last tick of the very last second of that entire cosmic year. This isn't meant to make you feel insignificant, even though it's the kind of fact that easily could. It's meant to help you actually feel, in your body, just how staggeringly, impossibly recent this entire moment actually is. You are not living through some forgettable, unremarkable stretch of an endless, uneventful cosmic history. You are living through the single most information-dense, most rapidly changing sliver of time in the entire 13.8 billion year story we've just walked through together, a species that spent nearly the entire length of that cosmic year as simple, unremarkable microbes, suddenly capable, in the last few seconds before midnight, of turning around and reading its own birth certificate. There's a phrase the astronomer Carl Sagan used decades ago that sounds almost too poetic to be taken as a literal scientific statement. And yet, once you've actually walked through this entire story from beginning to end, it starts to feel less like poetry and more like the single most accurate sentence anyone has ever written about what you actually are. He said human beings are a way for the universe to know itself. For 13.8 billion years, the universe existed, expanded, formed stars, forged elements, and built planets. And for the overwhelming majority of that time, none of it was observed, measured, or understood by anything at all. Galaxies formed and collided in complete silence. Supernovae exploded with a brightness that could outshine entire galaxies, and there was nobody, anywhere, to see it happen. And then, after nearly 14 billion years of that silence, on one small, unremarkable rocky planet, orbiting one small, unremarkable star, in one small, unremarkable arm of one ordinary spiral galaxy, atoms that had been forged inside dying stars finally arranged themselves into something capable of looking upward and outward, and asking what any of it actually meant. Not immediately. It took nearly 4 billion years of evolutionary trial and error just to get from the first self-replicating molecule to a brain capable of building a telescope. But it happened. And once it happened, the universe stopped being a silent, unwitnessed event and became, for the first time in its entire existence, something that could actually understand its own history. This is, when you actually sit with it, one of the strangest and most genuinely beautiful facts in this entire story. The universe spent almost its whole existence completely unaware of itself, and then, through a chain of events so improbable it should never have worked, built something capable of turning around and looking back, tracing every single step we've walked through together tonight, from the birth of matter to the death of the dinosaurs, to the exact atoms currently sitting in your bloodstream, and understanding, in careful, verified, mathematical detail, exactly how it all actually happened. You are not separate from this story, reading about it from the outside. You are the specific mechanism the universe eventually built, after nearly 14 billion years of trying, to finally read its own story back to itself. And here's the thing that should genuinely excite you about everything we've just covered. Rather than making you feel like the story is finished and there's nothing left to discover, almost every single chapter we walked through tonight still has genuine, unresolved mysteries sitting inside it, actively being investigated, right now, by scientists who don't yet know the final answers either. We still don't know what triggered cosmic inflation or what caused it to stop. We still don't know why matter won its near-total war against antimatter by exactly the margin it did. We still don't know exactly how non-living chemistry crossed the line into self-replicating life, despite nearly a century of dedicated laboratory research trying to recreate that exact moment. We still don't know what dark matter or dark energy actually are, despite them making up 95% of everything that exists. We still don't know why some of the earliest galaxies the James Webb Space Telescope has photographed appear larger and more mature than current models predicted they should be. This is not a story with a completed, closed final chapter, sitting quietly in a textbook, waiting to be memorized. It's an active, ongoing investigation, being conducted right now by thousands of scientists across dozens of countries, using telescopes more powerful than anything that existed even a decade ago, and particle accelerators capable of recreating conditions from the first trillionth of a second after the beginning of everything. Every single year, new data arrives, new mysteries get identified, and old assumptions occasionally get overturned entirely. The same way the discovery of accelerating cosmic expansion in 1998 completely upended a century of confident predictions almost overnight. This means that everything you just learned tonight, as carefully verified and as rigorously tested as it actually is, using two completely independent methods, reading ancient light and recreating early universe conditions in a laboratory, is still, in a very real sense, a first draft, a working model that gets refined, corrected, and occasionally completely rewritten as new evidence continues rolling in. The real story of the universe isn't a fixed, unchanging monument that human beings simply uncovered once and then filed away. It's a living, breathing, constantly updating investigation, and every single person watching this right now is alive during exactly the specific decade when some of the most important open questions in that investigation, what dark matter actually is, how life actually began, whether we're truly alone in the galaxy, might finally get answered. So let's bring this all the way back down to you, sitting wherever you're sitting right now, having just walked through 13.8 billion years of history in the space of a single video. Here's what actually happened, stripped of all the individual details, boiled down to its simplest, truest form. Nothing became something, by a margin so thin it should never have worked. That something spent its early existence in total darkness before finally lighting up with the first generation of stars violent enough to forge the raw materials of everything solid that would ever exist. Those materials got recycled through star after star, dying and exploding and scattering themselves across space until enough of them happened to gather together by pure gravitational accident into a planet capable of holding onto an ocean. That ocean, under conditions still not fully understood, produced something capable of copying itself, and that copying process, running continuously and without interruption for nearly 4 billion years, through ice ages and mass extinctions, and a genetic bottleneck that nearly ended the whole experiment early, eventually produced a species capable of building the exact instruments needed to look back across the entire span of that story and actually understand it. Every part of that chain had to happen exactly the way it happened, in exactly the order it happened, for you to exist at all. Not a slightly different version of you. Not someone similar to you. You, specifically, exactly as you are right now, reading these exact words, at this exact moment in the entire 13.8 billion year history of everything that has ever existed. That is not a small thing to have happened, and it's not a common thing either, as far as every single instrument we've ever pointed at the sky across 60 years of dedicated, patient searching can currently tell us. You are the temporary, improbable, unrepeatable answer to a question the universe has been quietly working on since the very first fraction of a second after it began. And whether or not you ever stop to think about it, that answer is currently sitting here, alive, breathing, thinking, and, for the length of this video at least, actually paying attention to the entire story of how it happened. Go outside tonight, if you can, somewhere dark enough to actually see the stars properly, away from streetlights and screens and the general glow of ordinary life, and look up. Every single point of light you see is a nuclear furnace, similar in kind to the ones that forged the exact atoms currently sitting in your bloodstream, some of them so far away that the light reaching your eyes tonight left its source before your grandparents, or their grandparents, or their grandparents' grandparents were even born. Somewhere among those points of light, if the math about 1 billion potentially habitable planets in our own galaxy alone turns out to be even remotely accurate, this exact same story, matter surviving its own near destruction, monster stars forging heavy elements, a rogue collision creating a stabilizing moon, chemistry crossing the impossible line into life, might be quietly unfolding all over again, on some other planet, orbiting some other star, completely unaware that it's happening anywhere else too. And somewhere in that same sky, hidden behind clouds of dust so thick that visible light can't even penetrate them, sits the center of our own galaxy, 26,000 light-years away, home to a supermassive black hole with a mass 4 million times greater than our Sun, an object so extreme that space and time themselves behave differently near its edge. And yet, it's just one relatively ordinary feature of one relatively ordinary galaxy, among the roughly 2 trillion galaxies currently estimated to exist within the observable universe alone. None of this makes the story you just heard feel any less real, or any less yours. If anything, it should make it feel more real, because it means the specific, improbable, unrepeatable chain of events that led to you wasn't some cosmic favor granted only to Earth. It was simply what happens, given enough time, enough raw material, and enough patient, unglamorous physics quietly doing its job for 13.8 billion years, whether anyone is watching or not. We just happen to be the specific arrangement of atoms on this specific planet, at this specific moment in cosmic history, lucky enough to actually notice. Here's a question worth sitting with before we close, one that almost never gets asked directly, even though everything in tonight's story practically demands it. If a single Mars-sized rock had struck Earth at a slightly different angle 4.5 billion years ago, or missed entirely, would there be no you at all? Or would there simply be a different you, shaped by a different, moonless Earth, with a wildly unstable climate, evolving along a completely different path toward a completely different kind of intelligence, one that might never have developed anything resembling human civilization at all? Nobody can actually answer that question with certainty, but the fact that it's even worth asking, seriously, carefully, without flinching away from how uncomfortable it feels, tells you something important about how fragile and how specific the entire chain of events actually turned out to be. Run the tape back and change any single variable, a slightly different mass for that hypernova, a slightly different trajectory for that asteroid, a slightly different chemical reaction in that ancient ocean, and you get an entirely different universe, an entirely different Earth, or possibly no Earth like ours at all. This is sometimes called contingency in evolutionary biology, the idea, championed forcefully by paleontologist Stephen Jay Gould, that if you could somehow rewind the tape of history and let it play out again from the beginning, you would almost certainly get a wildly different result each time, not because the underlying laws of physics and chemistry are random, but because the specific sequence of accidents, which asteroid hit, which planet, which mutation happened in which organism at which exact moment, is so sensitive to tiny variations that even a minuscule change early on cascades into an entirely unrecognizable outcome billions of years later. This is exactly why the phrase, "the real story of the universe," deserves to be taken so literally. It isn't a story about universal laws inevitably producing you, the way water inevitably flows downhill. It's a story about one single, specific, unrepeated sequence of accidents, compounding on top of each other for 13.8 billion years, that happened to produce this particular outcome on this particular planet, this one time. Somewhere out among that billion potentially habitable worlds in our own galaxy, the tape may have played out completely differently, producing planets with life unlike anything we'd recognize, or producing nothing at all, silent rock, orbiting silent stars, forever. We got this version, this one, specific, improbable version, and it's the only version any of us will ever get to actually live inside. There's one more twist worth adding before we head toward the end of this story, because it changes how you should think about everything happening right now in your own lifetime, not just the ancient past we've spent this entire documentary exploring. The tools capable of reading this story keep getting dramatically better, at a pace that would have seemed like pure fantasy even 20 years ago. The James Webb Space Telescope, which we've mentioned several times tonight, is already rewriting portions of the early chapters of this story, finding galaxies that formed faster and grew larger than anyone's models predicted, forcing scientists to genuinely reconsider parts of the timeline we just walked through together. Meanwhile, an entirely new kind of instrument has opened up a completely different way of reading the universe's history. Gravitational wave detectors, like the twin LIGO observatories in the United States, which first directly detected ripples in the fabric of spacetime itself in 2015, caused by two black holes colliding over 1 billion light-years away. Unlike ordinary light, which can be blocked, scattered, or absorbed by intervening gas and dust, gravitational waves pass through almost everything essentially undisturbed, carrying a direct, unfiltered signal from some of the most violent events in the entire universe, including, potentially, events from the earliest, most opaque period of cosmic history. The same 380,000 years of blinding fog we discussed near the beginning of this story, a period ordinary light can never show us directly because the fog itself blocked it. Future missions currently in development, including a planned space-based gravitational wave observatory called LISA, hope to detect ripples reaching all the way back to the earliest fractions of a second after the Big Bang itself, potentially the single closest thing to direct evidence of cosmic inflation that human beings will ever manage to capture. We are, quite literally, in the middle of building the exact tools needed to answer several of the biggest remaining mysteries in tonight's entire story, mysteries that have existed, unsolved, since the moment the universe first began. The real story of the universe isn't just something that already happened, sealed away in the unreachable past. It's a story that is still, actively, being uncovered, piece by piece, discovery by discovery, and the next major chapter might get written within the next 10 years by instruments that, right now, at this exact moment, are still being built. So here's where the real story of the universe actually leaves us, standing at the end of 13.8 billion years of accidents, violence, near extinctions, and improbable survivals, holding, in our own two hands, instruments powerful enough to keep reading the rest of the story as it continues to unfold. We are not passive characters in this story, simply along for the ride. We are, as far as we currently know, the only part of this entire, vast, ancient universe that has ever managed to turn around, look back at its own history, and actually understand it. And that gives the next chapter of this story a genuinely strange and genuinely significant weight. Every single risk we face right now, as a species, whether it's how carefully we manage the technology we've built, how thoughtfully we treat the one planet capable of supporting us, or whether we ever manage to actually find out if we're truly alone in this galaxy, is happening during the exact narrow window when the universe, for the first time in its entire existence, has something inside it capable of caring about the answer. Every other chapter of tonight's story unfolded silently, unwitnessed, indifferent to whether anyone was ever around to notice it happening. This chapter, the one we're all currently living inside right now, is different. Because for the first time in 14 billion years, someone is actually paying attention, and what happens next isn't decided by blind physics alone anymore. It's decided, at least in part, by choices made by a species that spent nearly its entire history as simple, unremarkable microbes, and somehow, against every reasonable expectation, ended up capable of writing, reading, and understanding its very own origin story. That is not a small inheritance to carry. It's the entire weight and the entire privilege of being the specific part of the universe that finally learned how to look back. Let's close with the same question we opened with, because after everything we've covered, it should land completely differently than it did at the start. What actually happened at the beginning of the universe? Not the cartoon version, the fireball exploding into empty space that most people carry around in their heads their entire lives without ever questioning it. The real answer, space itself stretched, everywhere, all at once, from a state hotter and denser than anything that has ever existed since. And in the process, something almost broke that should have ended the entire story before it even started. A war between matter and its own mirror image, decided by the thinnest possible margin. One extra particle for every billion destroyed. That's the beginning most people never actually hear, buried under decades of oversimplified textbook diagrams and cartoon explosions. And once you know it, once you actually understand what really happened in that first fraction of a second, everything that came after it, the 100 million years of darkness, the monster stars living and dying in violent, spectacular bursts, the moon-forming collision, the poison that became the fuel of complex life, the asteroid that ended the dinosaurs and opened the door for us, stops feeling like a list of disconnected facts you memorized once for a test and forgot. It starts feeling like exactly what it actually is, the single, unbroken, 13.8 billion year chain of events that had to happen in exactly this order for you to exist at all, ending, for now, right here, with you. Reading this sentence, at this exact, improbable, unrepeatable moment in the entire history of everything. That's the real story of the universe. Not a myth, not a simplified cartoon. A verified, tested, still unfolding investigation into how nothing became everything, and how, against every reasonable expectation, some small fraction of that everything eventually became curious enough to ask how it happened at all. If this video changed even slightly how you think about the night sky the next time you find yourself standing under it, that's exactly what this was made for. If you want more stories like this one, ones that take the real, verified science of the universe and actually make you feel the scale of it instead of just reciting numbers at you, make sure to subscribe, because there's a lot more of this story still left to tell. Chapters we haven't even touched on tonight. Black holes that bend time itself. The actual physics of what happens the instant a star collapses. The ongoing hunt for planets that might harbor life somewhere among that billion potentially habitable worlds sitting quietly in our own galaxy right now. This channel exists specifically to keep digging into exactly this kind of story, the real one, not the simplified cartoon version, and there's genuinely more of it coming. Before you go, one last thing worth sitting with. Everything in this video, every fact, every number, every dramatic turning point, came from actual, peer-reviewed science, verified independently, over and over, by different research teams using completely different methods, arriving at the same answers. This isn't speculation dressed up as fact. It's the actual, current, best understanding human beings have ever managed to build about where everything, including you, actually came from. And the fact that a species that started out as simple, single-celled microbes managed to build that understanding at all, using nothing but patient observation, careful mathematics, and thousands of years of accumulated curiosity passed down from one generation to the next, might be the single most remarkable part of this entire 13.8 billion year story. So the next time you look up at the night sky, remember what you're actually looking at, not just points of light scattered randomly across the dark. A visual record of your own origin story, written across a distance so vast it takes billions of years for the evidence to reach you, and somehow, against every reasonable expectation the math would have predicted, you were born at exactly the right moment, on exactly the right planet, made of exactly the right atoms, to actually understand what you're seeing. There's a version of this story that could have ended very differently, and it's worth sitting with for just a moment longer, because it puts everything we've discussed into its proper, sobering context. Every single existential threat currently facing humanity, nuclear weapons capable of ending civilization within hours, engineered pathogens capable of spreading faster than any natural disease in history, artificial intelligence systems whose long-term behavior nobody fully understands yet, climate instability capable of destabilizing the very agricultural systems that feed billions of people, exists precisely because we became exactly the kind of species this entire story describes, curious enough and clever enough to eventually build tools powerful enough to threaten the very existence that took 13.8 billion years of improbable accidents to produce in the first place. This isn't meant to end tonight's story on a note of fear. It's meant to end it with the same sense of stakes that every single chapter of this documentary has actually carried, whether it was matter fighting for its own survival against antimatter, or early life fighting to survive its own oxygen poisoning, or mammals fighting to survive in the shadow of dinosaurs for over 100 million years before finally getting their chance. Every single step of this story involved something almost not making it, surviving by the thinnest possible margin, and then going on to build something completely unprecedented out of that narrow survival. We are, right now, in this exact century, facing our own version of that same ancient pattern, standing at our own narrow bottleneck, holding tools powerful enough to either carry this entire 13.8 billion year story forward into a future we can't even imagine yet, or end it here, quietly, the same way it could have ended 1,000 times before if any one of those earlier accidents had gone even slightly differently. Nobody gets to know, in advance, which way this particular chapter turns out. What we do know, with complete certainty, is that every single generation before us that faced their own version of this exact same uncertainty, whether they were early monster stars, or ancient oxygen-poisoned microbes, or small mammals hiding from dinosaurs, kept going anyway, and their persistence is the entire, unbroken reason any of us are here at all to tell this story tonight. There's one more thread worth pulling on before we finally close, because it connects the smallest scale in this entire story to the largest one. And it's the kind of detail that documentaries almost never bother explaining properly. Everything we've discussed tonight, from the birth of matter to to the death of stars, to the formation of your own bones, ultimately comes down to 4 fundamental forces: gravity, electromagnetism, and the strong and weak nuclear forces, and the fact that these 4 forces exist in exactly the specific strengths they do relative to each other turns out to be almost unbelievably important. If gravity were even slightly stronger relative to the other forces, stars would burn through their fuel far too quickly to allow enough time for complex life to ever evolve on any surrounding planets. If the strong nuclear force were even slightly weaker, stars wouldn't be able to fuse hydrogen into helium at all, and the entire chain of stellar nucleosynthesis that built every heavy element in your body would never have gotten started. Physicists call this kind of observation the fine-tuning problem, and it remains one of the strangest, most actively debated topics in all of cosmology. Some argue it's evidence for an unimaginably large multiverse, where countless other universes exist with different physical constants, most of them lifeless and sterile, and we simply find ourselves in one of the rare universes where the numbers happen to work out well enough to produce stars, planets, and eventually, us. A selection effect rather than a coincidence. The same way you'd only ever find yourself wondering about the odds of your own existence if those odds had already worked out in your favor. Others see it as one of the deepest open mysteries in all of physics, a question our current understanding simply isn't equipped to answer yet. Either way, it means the real story of the universe isn't just about the sequence of events we walked through tonight. It's also about the exact, precisely calibrated rules those events had to follow. Rules so specific that even a tiny adjustment to any one of them would have produced a universe with no stars, no chemistry, and no story left to tell at all. There's one final piece of this story worth telling, because it's the kind of detail that tends to stick with people long after everything else fades. The specific, almost eerie fact that ties the entire beginning of this documentary directly to the entire end of it. Remember that first flash of light, released 380,000 years after the beginning, when the universe finally cooled enough for atoms to form and light to travel freely for the first time. That light is called the cosmic microwave background, and it's not just an interesting historical artifact sitting quietly in old data somewhere. It is, right now, tonight, still arriving. It has been traveling for nearly 14 billion years, uninterrupted, crossing the entire expanding universe, and it is still, at this exact moment, striking detectors, satellites, and yes, a small fraction of the static on old analog television sets everywhere on Earth, simultaneously, constantly, without ever stopping. This means the birth of the universe isn't sealed away in some untouchable, unreachable past, the way most people casually assume ancient history has to be, locked behind a wall of time nobody could ever actually cross or verify. It's still physically present, still arriving, still measurable, right now, tonight. While you read this sentence, scientists have mapped this ancient light in extraordinary detail, using satellites like the Planck spacecraft, finding tiny, almost imperceptible temperature variations scattered across it, differences of only about 1 part in 100,000, and those tiny variations turn out to be the actual, physical seeds of everything that came after. The regions that were slightly denser than average eventually became the galaxies, the stars, the planets. And eventually, through nearly 14 billion years of gravity patiently doing its work, you. The pattern of hot and cold spots in that ancient light is, quite literally, a direct baby picture of the exact structure that would eventually become everything, including the specific patch of stardust that became Earth, and the specific chain of atoms that became you, sitting here right now, still receiving, every single second, the actual physical afterglow of your own beginning. And that's the real story of the universe, from the very first impossible fraction of a second, all the way to you, right now, sitting here, having just spent the last little while learning exactly how unlikely and exactly how extraordinary your own existence actually is. Not a myth passed down without evidence, repeated simply because it sounds nice. Not a simplified cartoon explosion in an otherwise empty void, easy to picture, but wrong in almost every important detail. A verified, tested, still unfolding chain of 13.8 billion years of accidents, violence, near extinctions, and improbable survivals, each one setting up the next, each one absolutely necessary, each one leading, eventually, inevitably, impossibly, to this exact moment, this exact sentence, and this exact version of you. There's also a strange kind of comfort buried inside, knowing your own atoms are this old, this well-traveled, and this thoroughly tested by fire. Every difficult thing you've ever survived, every setback, every collapse that felt, at the time like it might genuinely be the end of everything, happened to a body built out of material that has already survived the near-total annihilation of all matter, the explosive death of at least one, and probably several, ancient stars scattered across billions of years and thousands of light years, a planetary collision violent enough to blast away a piece of Earth the size of the moon itself, and a genetic bottleneck that nearly wiped out the entire human species before written history even began to be recorded. Resilience, it turns out, isn't just something you develop over the course of one human lifetime, through hardship and practice, and slowly earned experience. It's baked into the actual physical material you're made of, inherited across billions of years of things almost, but not quite, ending, passed down atom by atom, crisis by crisis, survival by survival, until it finally arrived, intact, inside you. If you made it this far, genuinely, thank you for staying with the whole story, because most people never actually hear the real version, the one buried underneath decades of oversimplified textbook diagrams and cartoon fireballs. You now know something most people walking around right now simply don't. That the universe almost didn't survive its own birth. That darkness came before light. That violence built every atom in your body, and that against odds so overwhelming no honest mathematician would have bet on the outcome. Here you are anyway, alive, curious, and paying attention. Make sure to like this video and subscribe if you want more of the real story, the actual verified science behind the universe, told the way it should be told, without the cartoon version getting in the way, and without ever pretending the story is more finished or more settled than it actually is. There's a lot more of this story left to explore, and I'd genuinely love to keep exploring it with you. Until next time, look up, remember what you're actually looking at, and remember that you are, against every reasonable expectation the math could have predicted, the specific, unrepeatable, 13.8 billion year answer to the question of what happens when nothing accidentally becomes everything. And then, somehow, against every conceivable set of odds, starts asking why.